Okay, so I've given you a function now, an equation, and I ask you to find the inverse function. There's two ways to do this, sort of logically and algebraically. Now let's think about what's happening to x with the function. What's the first thing that's being done to x? -3 and then rooted. How do you undo? So if you want to undo that, if you want to take away all the operation to x, right? What do you have to do first to the result? Perfect. You square it and then? That's right. This is going to be the inverse function. That's how you do it logically. So that was the logical way. Algebraically, this is what you do. Algebraically, algebra method. Now, algebra method is useful for more complicated functions because you can't just guess like that for the harder ones. So this is what you do. This is what we have, right? X minus 3. What you do is switch your x and y value. Okay, because this is implied for that to be the input and this is the output, right? If you switch the x and y, you get this. This is my input now, and this is my output. And you isolate now your new y. Okay, if you do that, you're switching the input and output. Okay, and y will be the exact, you get the y by the exact reverse process of what you do to get the original y. That sounded maybe a little bit confusing. Okay, this new y you could get by doing the exact reverse process of getting this y, right? So square both sides and add both sides by 3. Look what we get. Same answer, right? Okay, so that was the easy part. What is the domain of this? You might be tempted to say it's everything. Right? It looks like it. If you look at that, right?
Yeah, but then you have to consider the original, right?
Yes. It doesn't matter what this looks like. It's always going to be the range of this function. Okay, so what's the range? What's the range of, I'm going to say since the range of the function, what's the smallest value root of x can be?
0.
Right, so let me actually draw that to even make it more clear. 1, 2, 3, that's what it looks like. Do you see that the range is greater than 0? That means the domain of this is going to be greater than 0. Okay. Oh, so since range is this, sorry. Therefore, the domain of the inverse function is x such that x is greater than or equal to 0. Okay, what is the range of the inverse function? Yeah, so the domain of this original function is greater than or equal to 3. So the range, same reasoning. When it's just say similarly, the range of the inverse function is going to be y value such that y is greater than or equal to 3, because the domain of this was x is greater than or equal to 3. Okay, the x and y value have to completely switch. Okay. Okay, let me do one more thing. Let me actually graph this, okay? X squared plus 3, that looks like this. Doesn't it? If you only draw it so that the domain is only greater than or equal to 0. Right. So, if you switch the x and y value, what you're doing is you're actually reflecting off the y equals x. Okay. When you graph it, if your algebra is correct, the graph should be an exact mirror image on the y equals x. Okay. And look at, see this step here I did earlier? I switched to x and y. That's equal to reflecting it on the y equals x line.
Oh, because all the x and y.
Yeah, all the x and y value switches.